Hey everyone, welcome back to the channel. In today's video, we're solving an easy but very common interview problem called Count Odd Numbers in an Interval Range. Let's understand the problem, look at the brute force solution, and then move to a highly optimized mathematical approach. First, let's understand the problem. You're given two non-negative integers called low and high. Your task is to count how many odd numbers exist between these two numbers, including both ends. For example, if low equals 3 and high equals 7, the odd numbers are 3, 5, and 7, so the output is 3. Another example, if low equals 8 and high equals 10, the only odd number is 9, so the output is 1. One important thing to note is the constraint. The values of low and high can be as large as 1 billion, which means we must think about performance. Now let's talk about the brute force approach. The simplest way to solve this is to loop from low to high and check each number. If the number is odd, we increase a counter. Here's what that code looks like in Java. Int count equals 0. For int I equals low, I less than or equal to high, I plus plus. If I modulo 2 not equal to 0, count plus plus. Return count. This approach works perfectly for small inputs. But the problem is performance. If the range is very large, this loop could run up to 1 billion times, which gives us O of n time complexity. That's too slow and will cause a timeout. So let's move to the optimized solution. Instead of looping through every number, we can use a mathematical formula that gives us the answer in constant time. First, calculate the total number of integers in the range. Total numbers equals high minus low plus 1. Then we use this formula to count the odd numbers. Odd count equals total numbers plus low modulo 2 divided by 2. Here's the logic behind it. If low is odd, the range starts with an odd number. So we'll have one extra odd number when dividing. If low is even, the odd numbers and even numbers are evenly distributed. Now let's implement this optimized logic in Java. Class solution. Public int count odds, int low, int high. Int total no equals high minus low plus 1. Int odd count equals total no plus low modulo 2 divided by 2. Return odd count. Then let's test this code with examples. For low equals 3 and high equals 7. Total numbers equals 5. Low modulo 2 equals 1. Odd count equals 5 plus 1 divided by 2. Okay. Let's come back to the text at the end of the chat list. So we'll have one extra odd number when dividing. If low is odd, the range starts with an odd number. Alright, let's move to the optimized solution in Java. Class solution. Public int count odds, integer, low, not equal, odd modulo 2, divided by 2. Here's the logic behind it. If low is odd, the range starts with an odd number and evenly distributed. Now let's implement this optimized logic in Java. Class solution, public int count odds, integer, low, high, minus low. 2 equals 3, vary. For low equals 8 and high equals 10, total numbers equals 3. Low modulo 2 equals 0. Odd count equals 3 plus 0 divided by 2 equals 1. Now let's compare the performance. Brute force approach, O of n time complexity. Optimized approach, O of 1 time complexity, and both use O of 1 space. Finally, let's check some edge cases. If low equals high and both are even, the answer is 0. If low equals high and the number is odd, the answer is 1, and that's it. We have successfully solved this problem using a clean and optimized approach. If this video helped you, make sure to like the video, subscribe to the channel, and comment down your doubts. Thanks for watching.